Here we are at episode 14, stream 14, of this series on making a game for the NES. Last time, in the last episode, we were going through some fine-tuning of the asset tool that we're building right now to allow for the game to make use of images that we create in whatever tool and save off as PNGs, and then use this asset tool to convert the images over to the NES, start building stuff around sprites and sprite collisions and palette data and all of that other stuff. And so we had started last week on validating that the images that we were using are not using too many colors. And then we also were working on exporting some of that data. As with the last stream, I had worked on the tool just a little bit before this stream, actually, just to tighten some things up. And also I fixed, if you recall from the last stream, we had moved the title screen, the compressed title screen tile information from the assembly directly into an include file, which was including a binary file. And if you look at what we have here, this binary file was just a direct binary encoding of the data that we had loaded up by hand, providing the compressed tile data to the game. There was a mistake that I had made previously where it was some of the data was bad, and it came from the way I was moving the data from the assembly to the binary in this Fred tool. So I got that cleared up, and so as you can see, we're back where we were with the title screen looking correct, and there's no crazy data other than some stuff that we will talk about in the upcoming portion of the stream here. So we've got our title screen, and then when we hit start, let the controller go to sleep. Oh, there we go. It starts scrolling. So anyway, that hasn't changed that much, but I fixed the title screen from last time. So let's get back into the asset tool here. So last time I had written some code to map the colors of the image straight from the indexed color, which should correspond to the indexed colors all that are possible for the NES as a whole. So the idea is that in whatever tool you're building your image, you work with the 64 color palette that the NES provides, so that when it comes into this tool, if you wanted to work in something like Photoshop, you have the ability to do that, and then when you load it up in the tool, it'll validate that the colors are not exceeded. So what this was doing was using a 64-bit integer to set each bit for the color that was set, and then counting up how many colors there are, and simultaneously making a palette of 4 colors for the image that we're displaying. And then based on the colors that are being used, we were remapping the indexed colors of the image from the absolute colors, so the color from the 64-bit palette on the Nintendo side, down to the index within this palette that we created from the 4 possible colors that it was loading. So effectively making it easier to go from our 64 colors down to the 4 colors. As I mentioned last time, there's some things you can do where depending on what you're working with. If you're working on sprites, each sprite can have a different palette, potentially up to 4 different palettes loaded at a single time. And same thing with the background. You're not limited to just one palette at a time, but for all intents and purposes, for what we're working on right now and for what we need right now, I think it's fine that we're just kind of limiting down to one 4-color palette just to start out with. And then we had included this button to export the image, and I had talked about how we wanted to do that and write the image data out to a file that we could view in YYCHR and also import into the game. I didn't do that on the stream last time because by the time we got to that point, it was a little bit late in the stream already, and I wanted to wrap up some of the other stuff that we were doing with the colors, if I remember correctly. So what I did was I got this part working by, taking the file name. Actually, we could probably move this into a function, but anyway, it's taking the file name, the full path name of the image that we're looking at now, replacing the extension or appending an extension if it didn't have one for some reason. It's saving it as a CHR file. It's opening and creating that file. And then, do we actually ever use this? We don't need this. And then we get to the sort of interesting part of this, which is the sort of tricky part of how all of this works. Because up until this point, most of this stuff is pretty straightforward. Like working with these images, obviously we're not decompressing the PNG ourselves, which isn't super difficult if you're using index colors. There are some formula that are in use for the different types of compression, and you do a search on Google, you can find what those compression methods are for indexed colors. They're pretty straightforward, but for what we're doing here, now that we have our indexed colors and we've remapped them to the 0 through 3, representing the 4 possible colors in our palette for the image, we now have to write that in a format that the NES understands. So I had mentioned last time that the way that a single tile is represented on the NES is it's actually a compressed image format. Since you can only have 4 colors, each pixel in the tile is actually represented as a bit in one of 2 bytes. And each byte represents 1 row of the tile. So, like I said last time, what you end up with is 16 total bytes for a tile, as opposed to 64 bytes if you were going to do an 8x8, right? Because again, the tile is just 8x8, but by doing this compression where you're saving the data in each of these bits, so you might have 0 here, and then you have 1 here, and then you have 1 here and 1 here, right? And each of these is a pixel, each bit is a pixel. You're saving on space, and I imagine that the reason that they did this split up like this is probably because it's faster to shift the bits off individually than decode them out of the byte. I don't know, that's just purely a guess, but there might be some sort of hardware reason that made it faster to do it that way. Regardless, so let's talk about how that works. So right now, if we have an 8x8 tile, we're talking about 60 on the PC side here. We're talking about 64 bytes, right? And it's just a linear array of bytes. And what we want to do is we want to turn this into 2 sets of 8 bytes, right? Because like I said last time, the bits are split up, and what we want to do is we want to say, okay, for this pixel, if this is 0, the first bit of this first byte that we're writing out is 0, and same thing for that one. And then if the next one is, say, 1, then we're going to, let me just look at my code here to make sure I'm saying the right values. We're going to write, is that the left? But yeah, so we're going to write 1 and we're going to write 0. And then if the value is 2, here we're going to write 0 and 1. And if the value is 3, we're going to write 1 and 1. And then we have 4 more bits here. 2, 3, right? But I wanted to show the different possible combinations of bits. And so this is, I'm representing this as left and right, only because when you lay it out in the file, instead of it being 2 separate streams distinct of bytes where you have all of these are really the higher order bits. Is that right? No, sorry, those are the lower order bits. So these are the the less significant bits in the binary value. So if you have 2 binary digits, this is more significant, this is less significant, right? It's storing the less significant bits here, and then it's not doing all just the lower significant or less significant bits and then all the more significant bits. It's doing a stream of first the less significant ones and then the more significant ones. So visually, when you're kind of looking at it, it's kind of like left and right, right? So hold on a second. I just realized I have Discord still running here, and I'm hearing the little chat notifications. All right, so how do we do that in our tool? So we're going to iterate over the entire image, right? And we're going to do it 1 tile at a time. So we're going to go through if we have a bigger image like this, we're going to write 1 tile chunk at a time, right? So we're going to iterate across the whole image 8 at a time, and then we're going to iterate over that smaller tile area 1 pixel by 1 pixel, or a pixel at a time over an 8 by 8 area, and we're going to store the bits into the appropriate bytes. And the way that that's done is a little bit complex. It's not hard. It's just it can be complex if you're not familiar with how all of this kind of bit manipulation works. So we'll break it down. So it's taking the current index value from that palette that we're working with. It is doing a bitwise AND, so it gets the less significant bit from that index. So like we said before, let's say the value is 1, it's going to store the value 1 in the left byte stream. And then if the value is something like 2, it's going to store it in the right byte stream. And it does that by doing a bitwise AND with the value 2, right? Because the bitwise AND with value 2 is going to give you only if the second bit is set. And by doing that, we get the 2 bits that we're interested in. The only thing is that this bit number 2, we need to shift over to position 1. The reason being that we then want to shift this into the appropriate position in this byte, right? So it's not enough to just get if we have a value of 2 in binary, it's not enough to just simply say, okay, I just want this to be the only thing set in that byte. Like, let's say there were other bits that were set to something else. I only care about those first 2 bits. It's not enough to get this. We also need to shift it over now to the appropriate position in the left byte, because we're iterating across the byte to set the individual pixel values from most significant bit to least significant bit. I just realized I probably don't need to do a shift 1 and then a shift here. So what it's doing, like I said, it's preparing that bit to be shifted now into the byte, but then it's shifting based on the current position in the tile. It's subtracting that from 7. And the reason it's subtracting it from 7 is that we only want to shift at most 7 places. We don't want to shift 8, because if we shift 8, it's going to go off it's going to get truncated off the end of the byte. So when tx is 0, we're going to shift 7 bits, and then 6 bits, and so on as we increase the value of tx and iterate across. But this actually, let's see, so we don't need to do this if we can offset it accordingly, so that we can be a little bit smarter about that. So actually, yeah, we don't need that other set of parentheses either. That was a holdover from copying this. So if we have this, it's already in the second bit, then let's see. So if this were the first value, and it was the value 2, and we wanted to shift that over all the way to the end, if we shift it over by 7, it's going to be 1 too many, right? Because it would already have been in the second bit position in the byte. So we really want to do 6 minus, is that right? And then let me think about that. So if we do it by 6, then we're going to get the right position for, yeah, you know what, we're going to do the shift just because otherwise we're going to run into a situation where we're going to get the tx is bigger than the 7, and then we're going to have a negative, and you can't do a negative shift, I don't think, or I don't know. I don't want to do that. Even if you can, it's just going to be confusing, and I'm not going to remember what the reasoning behind that was. So this is a lot more straightforward. Bit shifts are fast anyway, so I'm not overly concerned with that being a performance issue, especially given that this is a tool, and you know, right now at least we don't know what our performance bottlenecks are going to be. The other thing is, I noticed that I left in these prints, but we can talk about those. This was just for visual validation that the indexes were a specific value, and when we view this in YYCHR, just to validate the exported data, that it actually is what we were expecting to see, right? We want to make sure that we have some way of validating that we got the byte streams we were expecting. And then so once we get the left and right bytes set by doing an OR operation on it to set the bits accordingly, then we increment the byte index, because these left and right byte arrays are 8 bytes each. One set of 8 for each, the more significant bit and the less significant bit, forming 16 bytes for the tile. And then when we're done, we write first the left bytes and then the right bytes, and then we once we're done iterating over the image, we close the file. And then the other thing we're doing is we're opening up a DAT file, and in that DAT file writing out the values of the palette, so that when we look at this at in YYCHR, and potentially we may want this separately, although I don't know if we will want to for the game itself, but for now I want to write it out so we can look at the image in the appropriate color scheme. So that's it. I mean, it's again, it's not super complex, but it is a little bit confusing if you're not familiar with how bit manipulation works. So let's launch this. I added a new image in. This was just a character image I had from another project that I was working on a long time ago. You can see we've got 4 colors, and it doesn't exceed, because if it did, we would get this message again. And so when I hit the export image button, we still get our prints here, I'll probably remove those, but you can see it's printing out the indexed values of the colors based on the palette. And so just kind of as a visual verification, we can see that, you know, color 1 is in fact that sort of super bright green screen green. Color 0 is that sort of darker background color. And so that all looks like that's pretty good. We're not seeing any errant values that are bigger than 3, right? So that looks pretty good. And then if we go to YYCHR and launch that just to validate what we wrote to the file, we've got the, let's see, where did it, yeah, so we've got the file here. We load it up, and what's kind of cool is YYCHR knows what the palette file looks for a palette file that's named the same thing as the CHR file that you're loading in. So it automatically loaded the palette up based on that. And then if we really wanted to see sort of what this looks like, we can manually move these tiles around, and there you go. And that's what we expected it to look like. You know, the color representation is a little bit different, and that's primarily because of just the variation in palette with the NES. You know, as we've talked about, the palette representation isn't an exact thing, and a lot of people spent a lot of time trying to figure out what those colors should look like based on the NTSC output. All right, so similarly, we can do the same thing with our ship if we wanted to. You just hit export image, and when we open it up, YYCHR, no, I don't want to save that. There's the ship, and again, it loaded the palette, and we've got our tiles. And eventually, you know, we'll want to do something where once we convert this over to be a sprite, it will be smart enough to be able to handle things like mirroring, because we don't need these extra tiles since they're literally the mirror image of the ship. But again, that's as we move forward and as we build more stuff, we'll get to that. So that's all looking pretty good. It's kind of cool that the tool's handling that properly. I had to rewrite some of the logic in the button code to handle the clicking, because it was returning that the button was clicked continuously if you had the mouse down on it. So similar, it's actually sort of interesting, similar to what we did on the NES side when we were adding logic to handle button presses, where we didn't want the bullets to fire whenever we held the button down and wanted it to be actually only when we released the button. There's similar code now where we look at if the button is pressed or not, and if it's pressed, we set this button flag with the current state of the buttons, but return that the button wasn't pressed, the button wasn't clicked on. But then if the button isn't pressed, we look to see if it was previously pressed, and if it was, then we are going to reset, this is redundant code, reset the button state internally to be 0 and the flag there to be 0, and then we return back 1 that yes, the button was clicked on. If it wasn't previously clicked on, then you know, we pass on the state, because potentially we might want, you know, right click state or something like that we would check. We're not doing that right now, but we set the hover status there so that when you mouse over it, it still darkens the button even though it's not actually exporting anything until you click. All right, so that's pretty straightforward. And then it's basically we're at a point where we go, okay, so how do we get that into the game? So there are a few things we could do. We could, you know, append that to this fixed char file that we have here. But what I think I want to do, similar to what we did with the title screen, where we start doing something a little bit more flexible. So we do something like we have something called, you know, shooter ink, which is going to be our let's call it shooter char ink, which is going to be essentially the things that we want to include for our char ROM. And let's just create a brand new file here, and so save that and call it shooterchar.ink, and then we can have that include there, right? But let's include also let's include this new thing that we just generated from that image. So let's go back to this and paste it. So I've got this char file here. I don't want to put it before this because right now we're using the tiles that are in that, so it's going to mess things up. So I'll show you that in a second because it's kind of funny. But so all right, so we've got those two files now included. And when we go to run the game, you don't see anything different from this perspective. But if you go to the PPU viewer, you can see now that we have our image of the guy here. And if I change the palette, it doesn't blink anymore. Well, he looks a little creepy that way. So you can see our little character is now loaded in the char ROM for the game. So that's cool because that means that we've got that all loaded correctly. Now what we would be missing is the palette. So, I mean, in theory, we could even do the same kind of thing where we could load the palette hard-coded from a file into the set of palettes that we're loading for the system overall. The only downside to doing that is, realistically, we probably want to handle the palettes dynamically. As we're loading various assets, it should specify which palette of the set of palettes that we have in the game it's using, and so it shouldn't be a fixed palette. But let's try that just to get that to work, and then we can move on to the next part of the tool. So this palette, pretty drastically different. So it's 3027. Which one? Where is that being set? 0D00. I don't know what palette that is actually. I wonder if that's some sort of wonder if there's some sort of holdover from some other something that's loading incorrectly. So let's just try this. So that 27 is that guy there. Oh wait, no, it's just that first. Okay, it's just that first palette. Okay, so let's try this, right? So we'll do, instead of loading this directly, we'll say ink bin. Now for this, I think I can just load. So just load wrote the bytes directly, so it should be able to just load that file. We'll see. So that should be, this should be interesting to see, because I didn't try this. So, you know, this is like that whole, like I said in the beginning, the first stream, this is kind of a, as the Mythbusters called it, the collective ignorance thing, where I'm learning as you're learning. Oh, sweet. Okay, cool. That worked. So, yeah, there's the character with the right colors, and they're loaded in. And I had a feeling that would work, because it's just, like I said, it's literally just the bytes that we wrote to the file in the appropriate order. So there you go. So it went from the tool to YYCHR just for validation, and into the game by just including it in the assembly file. So any questions on any of that before I move on to sort of starting to export or convert these things over to sort of more of a sprite type format, where we can just include the sprite as a whole with the palette and that kind of thing? while I'm waiting to see if anybody has any questions, I'll do what I was doing originally just because it was funny the first time I tried that. So I had used the ink bin in the opposite order, and when I reloaded the game, it messed up the title screen because it included the guy there, and then he was part of the background tile set, which was causing it to look all weird. Got a kick out of that because it was just kind of funny to see the text blinking like that. So anyway, it's not up to date. I wonder if there's a way to make it figure out that you updated something. Alright, so we're back to where we were with the right palette and all that stuff. So that's good. Looks like no questions. Okay, so like I said, the next thing I want to do is I want to take this image and basically do something where I have a button to convert it to essentially a sprite. And the reason I want to do that is because, like, for example, right now, the flyby information, I think that's all hand coded in here as far as what tiles get loaded. Yeah, so all of that stuff is manually coded here, and what I'd like to be able to do is move some of that out. Like, the only thing that we've moved out data-wise is this bullet collision stuff. We did these bullet collision points where realistically, I was thinking about it, you know, we had done them as collision points, separate collision points. We're saving a comparison by only doing the 3 collision points, but I'm not sure that that's worth having then a specific implementation that supports collision points versus bounding boxes. I mean, obviously the bullet is going to have a pretty specific bounding box that kind of matches the size and ships to, and the bullet collision points worked well just because it was simple to implement that way. But it doesn't really, I mean, we're talking about one more comparison essentially against the bounding box of the flyby. So yeah, I'm not sure we actually save really anything by doing these collision points. I mean, I might be wrong, and we're going to end up having to switch over to just save a few cycles by not checking 2 bounding boxes where points would be more efficient. But I don't know. We'll see. So let's start with the first thing we need to do. So if we turn this into a sprite, I think the first thing we want to do is kind of collect together. Well, let's think about this for a second. So for the game here, what we would want to know, and this would all be relative to the project as a whole, potentially, as loaded by the game. But let's start with this. So we would want to know the tiles. I'm gonna make this a little bit skinnier. It's like too thick for me to write since my handwriting is so awful. All right, so we would want to know, okay, what are the tiles that we need to load? What's the palette that we need to load? What's the bounding box for the sprite? Potentially, if there are any animations, we would need to know that too, but we haven't gotten that far just because we're still pretty early on in this, and we're, you know, working on the getting the assets into the game in a simple way where we can swap things in and out pretty quickly. That's the idea. And the reason I'm focusing so much on this is it's like, yeah, it's really not hard to be typing in tile data or you know, sprite information into the assembly file when you have just a few files. But back when I was doing Game Boy Advance programming, we had some pretty basic tools that allowed us to do building of 2D maps and conversion of PCX files to tiles, because the Game Boy Advance uses tiles as well. And anytime we wanted to change anything, you know, so I'd get the changed artwork or the changed map from the person I was working with, and then I'd, you know, make sure that everything looked good. I'd convert it to a file that we could use in the code, and then I'd have to go manually modify the code to load the content properly because of all the changes that had been made. And it wasn't a self-referential system wherein that I had to put information into the game for it to understand enough about what it was loading so that it could load it properly. That's kind of what, you know, where we're at right now with everything being so hard-coded. And that just took forever. Anytime you wanted to make any changes, like if you wanted to change a map so that it was bigger, or it had a new tile set in it, or whatever, it just became a chore. And later on, we basically introduced sort of a concept of like a basic file system, essentially, where it was like, yeah, I need this map, right? And it then knew that the map was structured in a particular way where it could look up information about the map. That made things so much easier, because then there wasn't any real code changes. It was just generate a new map, load it into the file system, recompile the game. Well, the game would get compiled, and then you'd take the map data and actually got appended to the binary as part of the ROM, right? And then it knew how to find that content in the ROM after it was assembled. And then you load it up and it would be done. It would be something that used to take like 10 minutes to manipulate and get working, and then things would break and whatever. Now took, you know, 30 seconds. So the reason I'm spending so much time on building these tools is because realistically it's going to save us time as we get to points where we're changing assets and resizing things and changing bounding boxes because they're a little too big, or, you know, adding in new enemies. I want to be able to get that stuff done really fast and be able to focus on the actual gameplay and the gameplay mechanics when, you know, once we're kind of done building some, you know, reasonably good tools. All right, so yeah, so we need the tiles, we need the palette, we need the bounding box. I feel like I'm sure we need some other stuff, but realistically, those are going to be the minimum things we need. And so exporting the image is not really going to be a relevant thing for this button anymore. That was more for just testing out that we could. Oh, one other thing I forgot to mention is this actually works now. So at least the buttons and the color palette resize with the tool as you resize it. So that was kind of cool. Anyway, sorry about that. Just wanted to show that. So, all right, so we'll get rid of that export image button. We'll change it to be something where we actually convert it to be a sprite, which will essentially represent metadata about the sprite file, will represent metadata about what the sprite is in a format that's easy to use for the tool, and then we'll have a button that essentially exports the sprite in the component pieces and creates assembly code that we can include, and then once that's done, that included assembly code should, for all intents and purposes, be what we reference always in the game, and then, you know, we just keep updating the files that are referenced by that assembly that's generated, rather than having to go in and make any manual changes. I'd also like to be able to, you know, do some sprite touch-up here, or image touch-up, That wouldn't be hard to do, but I'm not sure we're going to do that right now, just because the I think the data management and the sprite management is going to be more interesting and more important to do right now. So let's get to that. Alright, so let's go back to the tool itself. Let's do a little bit of cleanup here. Like I said, we can export some of that functionality. So replace file extension, car, file name, file extension. So let's do that by stealing this code here. Yeah, and then replace file extension. I know that this is going to go away, but I mean the code itself is probably going to get reused once we are ready to export this content. But for now, I want to just make this, I want to rework this so that we're calling this function instead. All right, and then this is the file name. Yeah, all of those get renamed. Okay, so that's that, and then we have to do the same thing here. Replace file extension, new file name, .dat, and get rid of that. And then there was, we declared I. Yeah, that's good. So that should still all be good. So if I export that, let me delete the file from the NES Asset Tool folder. So we have our PNG and we export. And we still get our tile printout and we get our files. And if I go to YYCHR, just to verify that nothing got inadvertently broken. Come on. This was just generated and it looks good. It's got its palette set properly. Okay, good. I'm happy with that. All right, so like I said, now this portion of this, we're not going to need the export image, but what we do want to do is we want to add export char, export palette, right? So export char, we're going to pass it the image data, file name that we're exporting it to. And that should be it for that part. So, right, so that goes away now. We close that. We'll fix that in a second. So here's export char. So it gets the file name. And then we can just say image, and this is all good now, except for that. So, okay, so that's good. It's gonna write the file. And so now, again, we're just gonna, test the replacement here where we refactored this all out. And then we're going to call that export palette, palette, new file name. This is a bug. Let's fix that. Okay, so export palette. Oops. Okay, so this is all going to be the same except for when we actually go to write the palette. I actually don't even need. Just reuse this. That's fine. So in file equals 0, -1. Should be -1. File name. Come on. Our file name. If it was opened, we write it. That's good. New file name with a capital N. All right, so now, oh, I see what happened. I had that. Oops, that was just the curly braces. Okay, so export our char, export our palette. That should all still work still. Let's go back. And we export. See our print statements. I see our newly created files. Do I have YYC? No, I don't have it open still. So let's open that. And that's still good. Okay, cool. So now that that's refactored, I don't care about getting rid of it because we will be able to just call those functions super easily. It's not a big deal. All right, so we don't need that. What I'll do is I'll change this to create sprite. All right, so now in our 132 code, we want to look for. I'm all for using longer file extensions. OS supports it. It's, you know, we're not worried about 8.3 compatibility in older versions of Windows or DOS right now, and Unix systems don't care. So I'll just say it's a .sprite. Now we just got to figure out what we're actually going to put in that file because we're going to create a new one to start off with. So it's just going to be a struct. I think what I want to do is I want to have the file name. Well, I don't want it to be a pointer though. Oh, why not? We'll just go to 256 bytes. It's a PC. Everything is cheap, right? It's not like we need to support that on the NES. So the file name is 256 bytes. And we can just store the palette information right here. So those are the 4 palette colors. Do we want to store? I feel like we probably want to restore the re-indexed PNG so that we don't have to redo that every time. I'm just trying to think if there's any benefit into not doing that. I mean, obviously it's not ideal in terms of, you know, absolute storage space consumption, but we're not really talking about large images, and this way we don't have to re-index it every time. The palette on the NES is not going to change. Yeah, well, oh, but you know what? That's okay, so that's actually not a problem. So we'll do, here's what we'll do. We'll say, I was going to say the problem is that the size might vary based on the size of the sprite. But let's do this. We'll have a you know, unsigned. Well, it can be unsigned, but it doesn't need to be huge. We'll say unsigned short, width and height. So those are our 2 dimensions. Or do we actually? Yeah. Well, we want that because we need to know. And then so then the bytes that follow will be the indexed value. So for that, though, we can say image, right? This is just a reminder to myself. I know that, but basically what I'm saying is I don't need that. That was more of me thinking I need to explain that. So because we're writing this to a file, it's going to store. It would store a 4-byte integer, the pointer, because this is a 32-bit application instead of a 64-bit pointer. But that pointer is meaningless when you load the content from the file. We could even, exclude it if we wanted to be 100% safe about how we handle that. But it's meaningless because the next time we load the file from disk in a new session of the application, obviously it's going to do that into different memory. And that's especially true with the image data. I mean, it's true with all the data, but with the image data, because it might be varying different sizes depending on what sprite we're loading, we wouldn't have a fixed buffer that we would store in the file. We would want that to be variable, and we can calculate how big it is based on the width and the height, right? The width and the height times each other is the number of bytes that are used to represent the image in the palletized format. We also need the bounding box, so let's do that. We can do that here before we get to the image data. So unsigned short bounding box, and that's going to be that's 4 points with an x and y, so that's 8. That can be fixed because the bounding box is just a box. We need the xy coordinates for 4 points. That's not a big deal. I'm trying to think if there's anything else I want to include here. I think I'm probably just going to put something called buffer here and put, 256 bytes of just empty space. We'll call it reserved. I don't know. It's just, depending on what we end up doing, it may or may not matter, right? Because, like, let's say we're writing to our file with nothing in here, and then we realize that we need to add a new field. If we add the new field and it comes immediately after bounding box, any of the files that were written previously with the older version of the tool would not have the data in the reserved in the area immediately after bounding box, and so we would be loading that data as if it were the new data, but it would actually be image data. So that to that point, we probably also want to include something like a version, just in case, and that'll tell us if we need to bother looking at the 256 bytes that are in there. All right, so I'm okay with that, I guess. So let's do something where we have create sprite, source file name, which is the image, or so let's call it that, image file name. Width, height. I feel like we could probably get away with just passing the image. I think we'd be okay with just doing that because it's got the information we want about width, height, and all the index data. So we're good there. This is the palette. What else did I say? Bounding box, which will be just zeros for now because we don't have anything, and we've got the data. So we can do const car bounding box. I mean, if the bounding box isn't set because we haven't, no, we could create a bounding box based on the. Yeah, you know what? Well, that's what we'll do. We'll create the bounding box based on the size because this is only going to be called when we first create the sprite. It's not going to be called when we. It's not going to be called when we are loading the sprite or anything. This is actually creating the structure, writing it to disk, and then we'll be able to click on it on the left hand side. And that brings up another point that we haven't looked at yet, is tracking changes to the file system and getting those notifications, and that updating the list of files that we want to deal with, which we have a note about that because our file list is a fixed array, so it's not thread safe that we're going to be looking at that while it's being manipulated by an update from Windows. Well, we'll handle that in a second. So let's do this. Let's create a new sprite, and we'll zero it out, right? And then. What do you mean expected? Oh, did I struct? Oh, type def struct. All right. So we have our new sprite. We're going to copy the file name. File name 250. I'll fix that in a second. And file name truncate. So that 256 bytes should not be a fixed value. Const unsigned int max sprite file name max sprite. Palette is always 4, but you know, whatever. So, wait, what are you complaining about? Expression must have a constant value. It is constant. Can be used as a constant. Okay. Really? Yeah, I thought you could in C++. I thought I was doing that somewhere else. Did I think I was doing that somewhere else and then didn't do it? Those are my constants there. That is a const. Control buffer size. So what gives? What am I doing wrong? Const unsigned int. Oh, it actually has to have a value. Right. It actually has to be constant for it to be used as a constant. I'm gonna go full banana cakes here and just say palette size is 4. I don't know that it cost me anything. Do the same thing here. No, that's not what I wanted. All right. All right, so that's fine. That should be truncate. This should be max sprite file name. This should be palette size. If color map color count is less than palette size, is that, yeah, that's good. And then this is that, and that is also that. And let's see. Export palette. This is not going to work. Size of car times palette size. I'm glad. So I said that wasn't going to work, and then I thought, well, wait a minute, it did work because we tested that and it worked fine. And then I realized, well, yeah, it worked because I was checking the size of palette, which is a constant char pointer, which is 4 bytes, which just happens to be the palette size, but that was just a happy accident. It wouldn't have worked normally. Okay, so that's good. We don't need this anymore because I'm convinced that works. Alright, so I've got the new sprite file name. Let's see what else. The height, new sprite, width equals image width, new sprite. Palette, let's copy that with a mem copy. And then palette, and then sprite size, no, palette size. Right. So that's all good.